Okay, we're going to talk about projectiles now, part two. And when we do projectiles, and really what we're talking about here is if I have the ground and then I launch something and it makes a parabolic path. And there's a couple things we need to define. First is the initial angle, the velocity that the projectile takes off at, and we need to define the angle and the initial velocity, which we typically call v sub 0. So v0 has components in both the x and the y direction, and that's where we come up with these key ideas. So key ideas are, first of all, the velocity in the x direction is constant. The velocity in the y direction depends upon the initial velocity and then is affected by acceleration. The velocity in the y direction at the top is 0, and then we get the individual x velocity is the velocity initial in the x direction is v0 cosine of the angle, and the initial velocity of the y direction is v0 times the sine of the angle. Position in the x direction is given by the initial position plus v0x times t, and the position in the y direction is given by the initial position, v0y times t plus 1/2 at squared. And a in all of these cases is 10 meters per second squared. So let's look at a real life problem. Soccer ball is kicked at 20 meters per second at an angle of 37 degrees. So it goes off at 37 degrees and the velocity is 20 meters per second. So what is v initial in the y and v initial in the x direction? So v0x is 20 times cosine 37 degrees, which is 16 meters per second. v0y is 20 sine 37 degrees, so v0y is equal to 12 meters per second. How long does it take to get to the top? Well, if the initial velocity in the y direction is 12 meters per second, we know from experience that as we've done this a bunch of times before, we can write v is equal to v0 plus at, and I'll write that as 0 is equal to 12 minus 10t. T is going to be 1.2 seconds. So the time up is 1.2, and the time down is also going to be 1.2. We can confirm that in a few seconds, and seconds there, and we'll put time here, total time of 2.4 seconds. So one thing I can do is I can substitute in, take this equation, this number here, and figure out how far it goes. Because I know that the distance in the x direction is velocity in the x direction times t. So that's going to give me 16 meters per second times 2.4 seconds. And that ends up giving me 38.4 meters. And I can also get the height. Now they can do the height several different ways. One option would be what we've been doing all along, which is to say that the height y is v average times t. So that would say the average velocity is going to be 6 meters per second times 1.2 seconds is 7.2 meters. you could also do your v squared is equal to v0 squared 2a delta d, and that would give you the same answer. If I come over here, and I look at this total time equation, if I write that y is equal to y0 v0y times t 1/2 minus 10 t squared, and if I substitute in a t of 2.4 seconds, you'll find that y final is equal to y0. And I leave that for you to do at your convenience. Just to go back, we're going to add one important idea here is that time up equals time down, assuming that y initial is equal to y final. So the other interesting case is same ball, the same ball is kicked, is trapped at a distance 36 meters from where it was initially kicked. What's the height of the ball? So now I have, if you remember from the last slide, Vx is equal to 16 meters per second. Vy is 12 meters per second. So the time to get for the ball to get to the 36 meters is going to be 36 over 16. And that gives me 2.25 seconds. And from that, I can calculate the height. So y is y0, v0 in the y direction, t 1/2 a t squared. So that looks like y is equal to 0 plus 12 meters per second times 2.25 plus 1/2 minus 10 2.25 quantity squared. And if I do that all out, I find that the ball ends up having a final height, or a height when it gets received, of 1.6875 meters. And clearly, I would write that as 1.7 meters, but I wanted at least just to give you the numbers that I had. The final idea is what's the velocity of the ball at that point. So remember we said that the velocity initial in the x direction was 16 meters per second, and the velocity initially of the ball in the y direction is 12 meters per second. But I want to know what v final in the x direction. Well, that's just going to be the same that it was before, 16, because it doesn't change. But the final velocity in the y direction is going to be the initial velocity in the y direction plus at, and that looks like 12 meters per second minus 10 times 2.25 seconds. That gives me a Vy of minus, I think I got minus 10.5 meters per second. So one thing I could write would be the velocity is equal to 12 meters per second I hat. And actually, let me do this. V as a function of t would be 12 meters per second I hat plus, and then I would write the Oops, hold on a second. Sorry, guys. X velocity, so it's 16 meters per second I hat plus 12 meters per second minus 10t j hat at the velocity at 2.25 seconds would be 16 I hat minus 10.5 j hat. And if I wanted to do it in magnitude angle, the velocity would be 16 squared minus 10.5 squared. And that would give me 19.13 meters per second. And then the angle would be the arctangent of minus 10.5 divided by 16, which is equal to, which gives me an answer of minus 33.3 degrees. And that's because the ball is coming back down again, and that's that 33 degrees. So I think that's it. Hope this helped.